Hello friends, I am Professor Swanan Dongre and in this lecture we are going to study the BJT is construction. So what is BJT? BJT, as the name indicates, it is a type of transistor and it is bipolar junction transistor. Here the current flow is due to both electrons and holes, so that is why it is called bipolar, and this BJT is current control device. Now let us start with the construction of BJT. So in BJT there are three regions. First one is emitter, second base, and third is collector. Emitter denoted as E, base denoted as B, and collector denoted as C. So these are three regions. If you see the cross sectional view of BJT, so I'll draw here the cross sectional view of BJT. So here you are having three regions. The first one is emitter region, then the middle one is base region, and third is collector region, EBC, emitter, base, and collector. So emitter and collector, these are two side regions, while base is sandwiched, it is middle region. It is sandwiched between the emitter region and the collector region, right? There are two types of BJT. First one is NPN and second is PNP. NPN and second type is PNP. So in NPN transistor, the emitter and the collector, they are of N type material, while in PNP transistor, the emitter and collector, they are P type material. In PNP transistor, base is N type, while in NPN transistor, base is made up of P type material. So this is about the types of transistor. Here, if you consider the area of each region, at this diagram you can see that the base is having smallest area, while the emitter is having moderate area, while the area of collector is highest. So you can see here area of base is smaller than the area of emitter, and which is smaller than the area of collector. So this is the area, region wise area in the transistor. And if you consider the doping level, doping means number of impurities. The doping level of base is smallest, so base is lightly doped, D means doping. Then the collector is moderately doped, doping of collector is moderate, and the emitter is heavily doped region. So emitter is the heavily doped region. So here you can see that it is NPN or PNP transistor. There is no symmetry. At one side of middle region, that is base region, the doping is more, while at another side the area is more, right? So due to this unsymmetry, transistor act as an amplifier, which we'll see in next lecture. In transistor there are two junctions. If you consider a junction means PN junction. So here NPN, so first PN junction, it is in between emitter and base, and second PN junction is in between collector and base. So that is why first PN junction, it is called emitter base junction, and second PN junction, it is called collector base junction. In short, this junction between base and emitter, as the emitter is common, it is called emitter junction, while the junction between collector and base, it is called collector base junction. So in transistor there are two junctions, emitter base junction and second one is the collector base junction. So this is the transistor. So here, as there are two PN junctions in transistor, one PN junction corresponds to one diode. So that is why in transistor we can say that there are two diodes. It is just analogy. Actually, if you consider this NP, N type material means cathode, P type material means anode, again anode, cathode. So if I consider this NPN transistor, right, here we can get such analogy that first diode, it indicates the emitter base junction, while second diode, it indicates the collector base junction. While in PNP transistor you will get such analogy. Again here there is collector, there is emitter, then there is base. But my dear friends, it is just analogy. Here in this analogy, transistor can be treated as two diodes connected back to back. Back to back means anode is connected to anode or cathode is connected to cathode, and that middle junction is nothing but the base junction. But dear friends, here it is just analogy. We cannot have the transistor with the help of two diodes, because if you take two diodes having same specification, their doping and area will be same, and in transistor the doping in each region is different, the area is different. So this is all about the transistor, its construction. Now friends, let us see the symbol of the BJTs. So in BJT we are having two types, NPN and PNP. As the name indicates, NPN. In NPN, the emitter and collector, they are of N-type material, while the base is P-type material. And what is PNP? In PNP, the emitter and collector, they are of P-type material, while the base is the N-type material. Now see the symbol of both the BJTs, right? So here we are having मध्ये नाही यायचं बाळा, पडला होता पण नाही यायचं ना, शूटिंग चालू आहे ना. Now friends, let us see the symbol of BJT. So in BJT we are having two types, NPN and PNP. As the name indicates, in NPN the emitter and the collector, they are of N-type material, while the base is P-type material. And in PNP transistor, the emitter and collector, they are of P-type material and base is N-type material. As there are two types of BJT, hence there will be two symbols, one symbol for NPN transistor and second is for PNP transistor. Now let us draw the symbol of these transistors. So I draw here two symbols, and each symbol it is having three terminals. First symbol is of NPN transistor, second is of PNP transistor. So what is there in this symbol? In the symbol we are having symmetry, and at the center we are having terminal. Obviously it is middle terminal, it is base terminal. So this middle terminal is base terminal. Out of remaining two terminals, we are having remaining two terminals. First is emitter and second one is collector. But how to identify them in symbol? The terminal with arrow is emitter terminal. So this is emitter terminal which is having arrow. Again here the terminal which is having arrow, it is emitter, and the third terminal, remaining terminal, is collector. So the terminal with arrow, it is emitter terminal, and the remaining terminal is collector. And here, what is the significance of arrow? The direction of arrow. The direction of arrow indicates the direction of conventional emitter current. Now, what is conventional current? We know that conventional current, it is opposite to the flow of electrons. So it is opposite to the flow of electrons, and it is known as the conventional current. And in transistor, this arrow indicates the direction of conventional emitter current. So that is why in NPN transistor, as this arrow it is in outward direction, the direction of conventional emitter current is outward, that is out of the emitter terminal, while in this PNP transistor, the direction of conventional emitter current, it is inside the emitter terminal, that is inward. And we know that in transistor, emitter is heavily doped region. So that is why the emitter current will be divided into two currents, right? Here, if you consider this emitter current, it will be divided into two currents. First, it will be the base current, and second, it will be the collector current. Again here, the collector current and base current, they will be combined together to form the emitter current. So this is the symbol of transistor, and in the symbol I also shown the direction of conventional base current, emitter current, and collector current. Thank you.